experiment, we are going to find how the number of turns affect the strength of an electromagnet. The material required for this purpose is a copper wire, an iron nail, a spring balance, a battery and some connecting wires. Let us see how the experiment is going to be performed. You have to take an iron nail and wind this copper wire around it as shown in this figure, and you have to connect the two ends of the copper wire with the help of a battery. When the current flows through the wire, this nail starts behaving like a magnet, and at the lower end of this nail, because this is now an electromagnet, if you hold a spring balance, the hook of the spring balance will be attracted because the hook is made up of iron. So the spring balance will hang below this nail as you can see in this figure. Now using your hand or any kind of small quantity weight you can use, you can just hang it here at the hook, and you have to observe the weight when the spring balance just gets pulled away from the electromagnet. So that will be the force that is acting on the spring balance, the force of the electromagnet due to which the spring balance was held with the electromagnet. Now repeat the experiment by increasing the number of turns. You will find that as you increase the number of turns, the force required to detach the spring balance from the electromagnet will also increase, showing that greater the number of turns around the electromagnet, greater is the magnetic power generated. You can then fill in this observation table. When 20 turns were there, how much force was being exerted? For 40 turns, what was the force? And for 60 turns, what was the force?